examples of earthquakes. And earthquakes, there is a formula, and they would give you the formula. So we need to know how to use the formula as well, although with earthquakes, there is a shortcut for them that makes it easier. I'll show you with the formula, and then I'll show you how the shortcut makes it easier. Okay? The most intense earthquake, someone had asked about this, ever on the Richter scale is 9.5. I won't even demonstrate that with the desk. Okay? Calculate the intensity of the earthquake in Chile in terms of a standard earthquake. So we've got our formula here. The magnitude is 9.5. And I'm going to call this, since this is the Chile one, I'm going to put a little C there for the intensity of the Chile one over 7. And we want to get the intensity by itself, so I want to get that by itself. That's what this question is asking. And when it says in terms of a standard earthquake, it means that there's going to be the S, because that's the standard earthquake. That's going to be on the other side of the equation. So if I want to solve for the green thing, what do we do next?
Multiply the S.
Careful, that S is, it's a good idea, but that S is inside your logger. Okay? I'm not going to call on you, but if you think you know what to do next, put up your hand. Right, like, couple. Okay. The reason nobody remembers is because the next step is hard to remember. And you just proved it to me. We all didn't remember when you're solving for something inside of a logarithm. The hard thing to remember is you're going to have to use the definition and change it to exponential form. We first need a single logarithm. We have a single logarithm. So the hard to remember step would be, what's my base is 10. What's my exponent? 9.5. What's the inside? Intensity of Chile over S. And now you could get the intensity of Chile's earthquake by itself by multiplying both sides by S. And this would be in terms of S. Now, in the question beside, it says there Haiti experienced an earthquake of 7. Would you agree that if you put in 7 instead of 9.5 and did the same steps, you would get the intensity of the Haiti one to be 10 to the 7.0 times S? The math would be exactly the same. And this is where the shortcut comes in place for earthquakes. Earthquake questions usually don't say to solve for the intensity like this did in part A. Usually an earthquake question asks you to compare like they did in part B. How much crazier was the Chile one compared to the Haiti one? It's a lot. A lot, usually if you write that as an answer on the exam, they're like, I'll give you nothing. It is a lot, but how do we figure that out? Well, we would have to take one intensity, divide by the other intensity to see how many times bigger it is, right? Like, how many times bigger is 10 than 2? You'd be like, well, 10 divided by 2 is 5. It's 5 times bigger. So I need to take these two and divide them. I take my bigger one, the intensity of Chile, divided by the intensity of Haiti. And the intensity of Chile we found out was 10 to the 9.5 times S. And the other one was 10 to the 7.0 times S. Do you see that those S's really don't matter? They would just go away. And you're perfectly fine to do this as a shortcut. You can just go, I know that this one's 9.5, I know that this one is 7, my exponent laws say I should subtract 9 minus 7.5 is 2.5. And if I go on my calculator 10 to the exponent of 2.5, it is 316.228 times more intense. And a 7 is a big earthquake. And then you imagine that big earthquake and saying, let's do that 316 times bigger.
Is there a video of that?
In 1960, no, I don't think there was
How
much.
did they even record it in 1960?
The same way they record it now. They're like, we should, at some point, scientists say, we should be able to measure earthquakes. So they have that little needle thing. Have you ever seen it on movies?
Yeah.
There's a little piece of paper in this thing that is so sensitive that it can pick up stuff. And then when an earthquake happens, the needle goes back and forth like crazy.
In Winnipeg?
In Winnipeg, they're called seismographs.
Yeah, can we see a video of a seismograph though?
Oh, you just know you want.
That's in our invitation.
Well, if you think about it, Winnipeg might be one of the safest places in all of Earth.
There we go. There you go, kids. Is that loud enough?
How a seismograph works. A seismograph is an instrument used to measure the movement of earthquakes.
There we
A
go.
weight is suspended in a way that allows it to remain still when the ground moves. Most modern instruments use an electromagnetic mechanism for this. A writing instrument is attached to the weight, allowing it to record the movement as it happens. The word graph refers to the writing action. Most modern earthquake monitoring uses seismometers, not seismographs,
Ooh.
and record the movement of the earth digitally, or output the data to a seismogram, a printed version of the wavelengths on a large drum.
Makes sense.
These wavelengths that
Or more.
represent Earth's movements are so small that in order for scientists to study them, they have to be amplified.
Yep.
Then you see
There we go. There's our seismograph. So these questions, you can definitely use the shortcut. Compare two earthquakes, you just find the difference between them, and that's the power of 10. That's going to be the intensity. Question.
Would there be like an equation for a seismograph graph? Like y equals something something or whatever? Or like,
Well, what they're doing is they're like the standard is a certain amount of movement. And then it's just looking at comparing it to that original. So you're not weighing it, but you have to have some sort of standard to compare it to. And the standard they compare it to is things not moving very much.
that's not good.
Right?